Okay, so we have this alternate definition of the derivative at a given point, and it's actually a really useful tool for determining something about the differentiability, that is, the ability to find a derivative of a function at a given point. And we know that we're given this limit definition of the derivative, both forms actually, under the condition that f is a continuous function. So a natural question might come up. So does that mean that if we have a function that is continuous at some point x equals c, that it must also be differentiable at x equals c? Well, that is a good question. Let's talk about it, and let's use our example right here as our example. This function right here, f of x is equal to x absolute value of x minus 2. And let's discuss the continuity at the point x equals 2. Right? We might ask, okay, is it differentiable at x equals 2? Well, in order to be differentiable at x equals 2, that means that this limit would have to exist. All right, so what could we say? Well, all right. This function f of x equals x minus 2. Anytime we have an absolute value function, it's helpful to rewrite this in a piecewise manner, and we would do it here this way. We'd say, well, all right, the function absolute value of x minus 2 is just equal to itself. It's equal to x minus 2. As long as x is greater than or equal to 2, right? Because we know that we're either going to get 0 or something greater than 0 out, which is just itself. On the other hand, it's equal to the negative, its opposite, x minus 2, if we start substituting in values of x that are less than 2. All right. So we look at this function right here, say, all right, now let's evaluate this limit at x equals 2. So we're going to say c is 2 for the purposes of our definition up here, and try and find that derivative. So we would want to be able to take the limit as x approaches 2 of the absolute value of x minus 2 minus f of 2 divided by x minus 2. By the way, we note that f of 2 is equal to 0. Hopefully you see why. If you need to pause for a moment and figure that out, please do. So we're actually trying to take this limit as x approaches 2 of the absolute value of x minus 2 divided by the quantity x minus 2. And this is where we need this piecewise function, because we might actually have something different to the left and the right. So we need to take both one-sided limits right here. So let's take our limit as x approaches 2 from the left and compare it with our limit as x approaches 2 from the right. And in this limit, the absolute value of x minus 2 over x minus 2 in this version of the story, as we approach 2 from the left, that means we're approaching with values that are less than 2. So we're actually going to be taking the limit as x approaches 2 from the left of the negative of the quantity x minus 2 divided by x minus 2. And that just cancels it right out, and we're going to be taking the limit as x approaches 2 from the left of negative 1, and we know that limit is negative 1. Huh, interesting. So it has a slope of negative 1 at x equals 2, huh? Well, let's take a look at what happens from the right. We're taking the absolute value of x minus 2 divided by x minus 2, and we say, well, that's really the same thing as the limit as x approaches 2 from the right of the quantity x minus 2, right? Because if we allow values of x that are greater than 2 into the story right here, that means we have to use this upper part of the function, divided by x minus 2, but there's no negative sign right here, but x minus 2 and x minus 2 cancel each other out, and we're left taking the limit as x approaches 2 from the right of positive 1, and that is positive 1. Now, if you remember, this is a two-sided limit, and we said that two-sided limits, one of the conditions under which two-sided limits will not exist is if we get different values from the left and the right. And lo and behold, we get two different values. They don't equal each other, and we would say then that this limit fails to exist. If we look at what this means for a minute right here, here's the graph of y equals absolute value of x minus 2, and we see exactly what the problem is. Right here at this point, 2, 0, we see that if we let x approach from the right or the left, we're going to have two different slopes, and that kind of thing can't happen. We're going to find that there are certain functions where when we come to this kind of behavior, where we have a different slope on the left and a different slope at the right, we call this a point of non-differentiability. So we would say that this function is non-differentiable, at the point x equals 2. So now we know.